Hello, peeps and peepettes. How y'all doing? This is Miss Harper. My hair looking a little wild. Let me kind of swoop it up a bit if I can, kind of neaten it a bit. It was really cute for church yesterday, but you know how it goes. After you come home, you go to sleep, and you don't care. And then I had dialysis today. So, you know, I just wasn't in a cute mood today. But I'm okay in Jesus' name. All right. This is a special request from one of my GED students. I think I'm going to angle the camera this way because I'm right-handed. So I'm going to angle the camera this way so that I can write on it. And I'm still trying to get up to date on technology, you guys. I love technology. I'm just a little slow, and I like to learn stuff first and see what I'm getting into before I go out and buy it. So now that I've learned about Logitech, webcam, and just learned about plexi boards and doing a light board with the LED lights and all that fancy dancy stuff and getting a black backdrop. I'm going to go out and buy some of these things on tomorrow. So wish me well. So that way I can be more effective in my teaching and relating via the internet or via YouTube. Okay. Because I love teaching. I just want to be able to teach from home. Because I have dialysis, and there are some days I feel great, and there are most days I feel blah. So I had to have some Zofran earlier today, which kind of helps me, but it makes me sleepy. And so I'm just going to teach this lesson today. And this is for my girl, the Pixie. She know who she is, the Pixie. She know who exactly who I'm talking to. So I'm just going to teach this tonight, and then hopefully tomorrow at some point I'll make some more videos because you had questions about exponents and roots. Okay. All right. So I'm going to be reading from my handy dandy GED book here, and I'm going to send that to my student. If you want a copy of this, you would have to email me so that I can send it to you. Okay? And I'm going to write my email down so you can email me here, thcod@hotmail.com, thcod@hotmail.com, or you can email me at the GED school at outlook.com. Okay. The GED school at outlook.com. So I pretty much check both emails a lot. Those are both my business emails that I check on a regular. And then put in the subject heading, math question or YouTube question or YouTube math question. I also teach medical billing and coding, health information management. I'm going to be working on stuff with that, coding, stuff like that, medical coding, not computer coding. I'm not good with that. That's not my thing. So anyway, just email me and put in subject heading, question, math, question, medical coding, question, GED, whatever that is. Okay. All right. So exponents. Why? My angle is wrong. Let me fix that. I told you I'm not the best person, but I try. Okay. Let me scoot this way. Okay, great. So exponents. And you're probably wondering, well, why do I need to know exponents in roots? Why do I need to know exponents in roots? I tell you why. Because some jobs that you work on may require for you to write some scientific notation. It may require for you to have some basic knowledge of that, or maybe some basic knowledge for statistical reasons. Okay. My husband is a chemist. And so he writes and understands scientific notation a lot. So in his field, along with everything else that works, all glory in chemistry, chemical engineering, all that beautiful stuff, they have to know this stuff. Okay. All right. So I'm going to read this here. And it says X are used to simplify a problem that calls for repeated multiplication. The expression 5 to the third power, or we say in 3, cube. Okay, that's another terminology, cube. Okay, so it's read 5 to the third power, or 5 cubed. Has a base of 5 and an exponent of 3. The exponent tells how many times the base should appear in multiplication. Okay, so let me this demonstration down. So it says 5 to the third power. Do you see that? 5 to the third power? Okay, great. So 5 to the third power is 5 times 5 times 5. Now, dots in algebra or some other higher form of 5 times 5. Okay? And both of these would equal up 125. They would equal up 125. Okay? Now, you're probably saying, well, Ms. Harper, how do you know that it equals up to 125? I'm glad you asked. So let's break it down. Okay? So we're going to look at these two right here. We know that 5 times 5 is 25. Okay? Then we're going to bring this down. Okay? And we're going to say 25 times 5, because we brought this 5 down on the end. So we know that it takes 4 quarters. Each quarter is 25 cents. So we know it takes 4 quarters to make $1, right? If I have 5 quarters, then that's $1.25. Okay, that's another way to look at it. But in this regard, since we're bringing down this 5 right here on the end, we're saying 25 times 5 is 125. Okay, does that make sense? Okay, I thank you. I want to say I think you got it. Okay, now let's look at 12 to the second power. We know it can be 12 times 12 equals 144. Okay, or we can say 12 times 12 equals 144. Okay, do y'all see that? Okay, fantastic. 12 with the multiplication sign. All right, super fantastic. So again, we know in normal math, if you know your times tables, 12 times 1 is 12, 12 times 2 is 24, so on and so on and so on, until you get to 12 times 12. You know that's automatically 144. Okay, so again, we have simplified by multiplying just these two numbers. Okay, now let's look at 2 to the fifth power. You have to always remember. All right, fantastic. All right, so we know that 2 to the 5th power is 2 times 2 times 2 times 2 times 2. So we have to write 2 how many times, ladies and gentlemen? 5 times. Exponent is 5. Okay? All right. So that's 2, 3, 4, 5. All right. Now, for some of you that have preferential of how it should look, you can do 2 times 2 times 2 times 2 times 2. Okay. All right. So we know that this is going to be 32. Now, since I have worked out the first problem with 5 to the third power, what do you think I should do to get to the answer of 32? What is the first step? And the reason why I'm teaching this because I'm going somewhere with this, and I'm going to teach you another kind of math that is similar to this, okay? But we'll talk about that a little later. All right. So you got 2 times 2 is 4, okay? Times 2 times 2 times 2, okay? Great. So now we can say 4 times 2 is 8 times 2 times 2. Okay? Now we can say 8 times 2 is 16. Okay, yeah, 16 times 2. So 16 times 2 is, and I'm running out of space here, 32. Do y'all see how Miss Harper did that? Do you see how Miss Harper did that? Okay, so when we get ready to work on some other math problems later on, I want you to remember how I worked this out, how I did this, and it'll come easier to you, okay? It'll come easier to you. All right, let's look at some other problems. So I'm going to paste another sheet of paper here. Give me just a minute. I know the era of technology. I'm catching up, beautiful people. I am catching up. Hold your horses. I am coming. Give me a minute. Okay, fantastic. Fantastic. Okay, now let's talk about 10 to the third power. 10 to the third power. How are we going to express 10 to the third power? Can you tell me how we're going to do that, boys and girls, ladies and gentlemen? Okay, very good. So we're going to express it 10 times 10 times 10. Or we can express it 10 times 10 times 10. Okay? Very good. So we just expressed what is 10 to the third power. Okay? Very good. So now we're going to solve this. We need to find out what is 10 to the third power or 10 cubed. What is 10 cubed? Okay. So we're going to take these and we're going to multiply this, and this is going to be 100. And we're going to do this. So 100 times 10. Can anybody tell me what 100 times 10 is? Okay, very good. 1,000. 1,000. Oh, we can write it over here. 1,000. Okay. Very, very good. Now, how writing exponents or expressing exponents when you have a negative exponent. In exponents, you have your zeros to the right. Okay. Now we're going to do exponents to bases times negative exponents. This time it's going to come to the left. Okay. All right. So let me write this on here so you don't get confused. Okay. Negative exponents. Negative exponents. Okay, let me turn my heating pad on. It's my back starting. Heating pad on. All right. So let's do 10 to negative 1. Okay, negative 1. So remember the decimal system? Remember the decimal system? Okay, so I'm going to write a little caveat here. Decimals. Okay. Decimals expressed in fractions. Okay. So remember in decimals how we would have 0.5 or we would have 0.05 or we would have let's make up a number, 007 or we would have 0.0008. I'm just making up a number, okay? It doesn't have to really mean anything. All right. So we know that 0.5 is in the ones place. Remember place value? Remember what I said earlier before. Math is learned in layers. When you learn your foundation, you learn your place values, you learn your decimals, you learn your fractions, you learn your ratios and proportions, you learn your measurements, you learn then once you learn that, then the order of operations. Once you learn the order of operations, then you learn pre-algebra. Once you learn pre-algebra, then you can appreciate algebra 1. Okay, and distribution and associative distribution. And then once you learn all of that, then you learn coordinates. And once you learn coordinates and all of that, then you learn geometry. Then you learn Pythagorean theorem. I can't never hardly say that right, but you know what I'm saying. Okay. All right. So this is in the ones place, right? This right here, the 5 is in the what? It's in the tenths place. No, I'm sorry. Tenths place. I wrote that wrong. Hundreds place. Thousands place. Let's see, tenths, hundreds, thousands, tenths, hundreds, thousands, 10,000. Okay, then this is the 10,000s place, and so on and so on. So you'll know how to properly convert your decimal to an actual number. Okay? All right. So if I were to say 10, then I would express 10. Okay? I would express 10 one place over. Okay? So 10 to the first place is going to be 10. Plain old 10. Okay? if I were going to do 10 to the, let's see here, let me choose one. 10 to the, oh wait, I'm sorry. Your denominator and numerator. So this is in the 10th place. So this would be 1/10 or 1/10. Sorry, I wrote that wrong in the first place. I knew it was something wrong when I looked at that. Or 1/10. All right. This right here, 10th to the third place, to the third, negative third power. Okay. So we would have 1/10 times 1/10 times 1/10. Okay. And we already know that this is going to be in a thousands place. Okay. So we have 0, 1, 10,000, 100,000, 10 to the thousands place. 10 to the thousands place. Okay. This will come 3 dots over. Okay. So in other words, if I were to write this, then I would move this over, since we already know that means 1,000. I would move this 1, 2, 3. Okay. Oh, wait. That. Okay. That's how we do that. Scientific notation. Okay. Now, let's look at some more of these. Okay. So we have, I'm running out of space, 93 million. Okay. How do we write that to a decimal in a scientific notation? Well, we got to count how many zeros that we have. We have 1, 2, 3, 4, 5, 6. So instead of this being 93 million, we're going to move this over and put a dot right here and cancel the rest out. And we're going to count 1, 2, 3, 4, 5, 6, 7. Okay, so this will be 9.3 times 10 to the 7th power. Because this was already moved over 6 places, we needed to a scientific notation to get what we need out of 93 million. So we're going to move this comma over 1 space, and it's going to be 9.3 times 10. So your 3 is inclusive in the count of the numbers of zeros that you're counting. So it'll be 9.3 times 10. And then there's a way you can use exponents on your calculator. You have to press a raise button or something on your calculator. If you have a Texas Instrument calculator, if you have a graphing calculator, you can do exponents on your calculator. And one day I'll have a class on that, but not right now. Okay, so really you would write 6 zeros and 3 would make your 7th number. 3 will make it your 7th number. Okay, so what I'm going to do is in this video right here, I want you to tell me what you think. Ms. Harper, you could do better. You need to get better technology, la, 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 la. I'll read some things. I don't read everything. I'm sorry. I just don't. But I love good, constructive things, if it's going to help me. All right, great. Okay, well, thank y'all so much for this short lesson on exponents. I haven't gotten a chance to do roots just yet, but I will. Okay, I will. All right. And that'll be all for tonight, boys and girls. We'll have some more lessons on exponents and we will finish teaching on roots. Okay. Good night. It is 7:30. Miss Harper is tired. I had a very long day. God knows I love y'all, but I've had a very long day.